Great. Okay, so we're going to go ahead and get started. Welcome to Marcus Eck and Laura Marks with PIEPS. They're joining us. One of the coolest things I think about this age of Zoom is that we can have a webinar with folks who are overseas in Europe. So it's 5 o'clock for them right now. So thank you for joining us at the end of your day. Those of us here in the Mountain Time Zone are just getting started. So we're really excited to talk or to learn a little bit more about some of the basics, obviously, of the beacons that you manufacture, but also about optimizing that search device performance and learning a bit more about the interference. For instructors that are joining us today, I'm grateful to get a chance to learn a little bit more about those beacons that students might show up with. And also, of course, instructors tend to be the kind of folks who geek out about gear. So always excited to learn about special features and be quietly shopping around for their own next beacon. So with that, I'm going to turn it over to the two of you. Folks, if you have questions, I'll have you drop those in the chat, or at the end of the session, we'll have time for a Q&A so we can read your chat questions then, or you're welcome to use the hand raise feature and I can give you permission to speak so that you can just ask your question to our panelists. So with that, I will stop sharing my screen and turn it over to you two.
Okay, thanks for this nice introduction. Hello, everybody. My name is Marcus Eck. Greetings from Austria. We do not have that much snow currently. We have great weather and snow is coming soon the next days again. So we're looking forward exactly this. As always, you know, for season start, I would say, and we are late on that, I know, but it's always helpful to review and to remember the knowledge of snow safety, but also to train on the product, what you own. The goal of today is to give you guys some background knowledge, which should be additional to your practical experience, what you already have. So we explain some things from the technical perspective and what that means for practice. So I try to share now my screen here and we can start immediately. Well, I think that should work, right?
Yep, that's working for me.
Perfect. Perfect. Yeah, full screen. Yeah. Well, before I start with the main topic of this webinar, just some small words in short about PIEPS. PIEPS is really well known globally for its experience in avalanche transceiver technology and developing and selling beacons. PIEPS is doing that since over 50 years meanwhile, and always on this premium performance level. But parallel to the technology of the beacons, we also offer different products, all related to snow safety. It means we have this airbag system called JetForce. It is the only and really best performing airbag system, and the only in electronics, which is available on the market. We also have probes and shovels. Yeah. We have some rescue equipment around with BB bags and first aid. Scherst du die dem Heinz ab an Winksken, bitte? Yeah. Yeah. We also have backpacks and shovels, so the whole beacon and snow safety system around snow safety. So the headquarters is in the southeast of Austria. It's near Graz, the second biggest country of Austria. It was founded in 1972, but we have roots back in development to 1968. So the oldest beacon I'm aware of is really from 1968, which was developed together with the Technical University in Graz. And this was the very first beacon on the market from our perspective. Well, let's start with the main topics, and we have prepared 3 main topics. This is the search strategy and range. We talk about what we call the fastest rescue system, and we talk about external influences and interferences. So the start is about the search, and it is about the range. With some basics, but it's important to have everybody aligned. I do not know the level of this group of people, so sorry if this is already known, but let's align on the technology piece on avalanche transceivers. So beacons are transmitting with the 457 kilohertz, which is a European standard. And all the beacons need to work with this frequency in transmit or in receive mode. So each beacon in transmit mode, it transmits the signal with 457 kilohertz. It is plus minus 80 hertz per definition of this EN 307/18 standard. The transmitter transmits based on the electronic flux lines. And let me go back. Yeah, you see here these flux lines from the transceiver coming out in a 3-dimensional way. And each receiver follows always this flux line. So it's never the direct way to the transmitter. It is always the flux line what the receiver follows. So the receiver itself, it understands this 457 kilohertz transmit signal. It is defined by these pulses, and also with these differences between the different pulses, it is allowed to be between 1000 plus minus 300 milliseconds. The pulse itself is bigger or the same than 70 milliseconds, and the pulse is bigger or the same than 400 milliseconds. So each transceiver has to transmit in this frequency of 457 kilohertz plus minus 80 hertz. Each receiver has exactly this receiving definition, and this makes it possible that all the beacons which are used globally can understand each other, and we as a brand can optimize the performance also based on this defined standard. Today, all the beacons are digital. This means this works really on a signal identification based on the frequency, on the pulse length, on the period. And all happens through signal processing. Analog beacons, you normally never find that again in the field, and this is good because also electronic gets older, in particular when you use it in these hard areas like winter, minus degrees, etc. Well, when we talk being outside and really something happens, then let's align in short on these different search phases. If really something happens, you have this point where the avalanche goes down. You have to focus where you have seen last time the victim, and after that the real search for companion rescue in particular starts. This is defined globally by the signal search. It follows up by the coarse search, and after that with the fine search and the pinpointing to finalize. The signal search here, you're searching with your eyes and with your ears. You're looking if you see something, and you're looking also on the transceiver. The speed here is fast. You see and what you hear. The accuracy is not that good for sure. Your speed is high. That's a reason, and you should have in mind, based on the definition before, each transmitter only transmits a signal each second, not faster. This is per definition. So if you run faster than 1 second and the next second when the pulse is coming, your receiver cannot receive more than the transmitter transmits. After that, on the course search, you have the signal already on the display, and then you follow the arrow and you follow the distance indication on your beacon, following the flux line until you're coming closer and closer to the victim. And this is called the fine search. And from a distance of 5 meters, you go down on the snow surface like an aeroplane. You slow down with your speed, and automatically your accuracy becomes better and higher because of getting slower. Remember, each second one transmit signal. So if you move faster, you overrun this transmit signal easily. And during the pinpointing with the probe, this has to happen systematic. And here again, you take care about accuracy and not about speed. After that, if probing is successfully, you start shuffling, you start digging out the victim, and this you always have to probe 90 degrees based on the surface, and based on the distance you measure with your probe, you know the distance from where you have to start. And best possible, there is not only one shuffler, there are more than one, so you can make a shuffle rotation, and you're much faster and to dig out the victim. Well, then let's talk about what this search phases means for beacons, and the transceiver performance. On signal search, this means I have no signal already on the display. And here it is super important to, in our understanding, to have a beacon which gives you a recommendation and works really with useful range and with the high quality of the first signal. So you have no ghost signals on your display. And as soon as you have the first signal on it, that you have a really high quality and correct, reliable direction indication and distance indication, which leads you along these flux lines until you come to these 5 meters of the fine search. And here in fine search, the receiving range of the third antenna is super important, because if you have a third antenna with the right receiving range, you will not have multiple maximas as you have it with 1 or 2 antenna, or with 3 antenna beacon, which only have a small receiving range on the third antenna. For multiple burial, the quality of the mark function is absolutely the point. Means you find the first victim, you press the mark button, and automatically your beacon shows you the next strongest signal, and only this on the display. Means the one you followed before marking. This is not furthermore the strongest. It is now the second closest based on the flux line, the second closest beacon. And this one you will find by following this new arrow and this new distance indication in the same way as you did find the first one. Well, so let's focus more on the topic signal search, because range is important, and you will hear that from it during this presentation more often. But the best thing what you can do when you have no signal on your receiver, you keep the receiver in front of your body, away from possible interferences like your mobile or a radio. You're moving fast, You're looking around on the surface if you see something. You're looking also permanently from time to time on the beacon itself, what is shown. Do you have already received a signal? And on our beacons like the ProBT or the MicroBT, also a Vibra is included, means you can look around with your eyes, you can listen without looking on the beacon. But as soon as there is a signal, you feel a vibra, as you know it, this vibration from your mobile, for instance. It gives you an indication in your hands, and then you start looking. And this is also very helpful during your run or moving on the avalanche. It's better to look around, having your head not down on the bottom and on your screen of the beacon, so you move better, faster, more safe without falling. And as soon you feel this vibra, you start looking on the beacon. So it's important to have the best method here chosen. Means one rescuer goes this meander. If you have skis, you go in this way, as the graphic shows with the skis. And the best is for sure, again, if you can organize this rescue as a team, so you're much faster, because then you take the recommended search trip with, go in a row down, and not like a meander or this zigzag down to find something. So why is a big range important? And these pictures should explain this. We have here the transmitter of the victim, the same on the other picture. And here what you see is the trajectory, the way of the rescuer having a beacon with the big receiving range, more or less circular. And this means having a big range and a search width of 50 meters possible. In this example, after 2 minutes and 20 seconds, a first signal is found. And from here, the rescuer can follow he only has to follow what the beacon says, follow the arrow and looking if the numbers counts down, which are shown on the display. Here in this, you have a short range. It is an elliptic shape, as you see. So you have to run in 20 meters, and automatically you have the 6 minutes and 30 seconds. And we all know what that means. In the statistic explains to us, you have 10, maximum 15 minutes to locate, to find, to probe, to hit the victim, and then to shuffling out for this 10 to 15 minutes. So being fast is more or less the equivalent to a big range. Means a big range is a big search trip width. It is an early first signal, and this means fastest possible rescue. So summarized, big circular range is an advantage in signal search and core search. The useful range is a reliable direction and distance indication from first signal, independent from the coupling position between the receiving and transmitting beacon. And it is super helpful also for the performance. If you keep your transceiver independent, which brand it is, in front of your body, it has a significant advantage in performance. So the range itself, it depends by the signal strength of the transmitter, by the size of the antennas, and by the coupling position between the transmitting beacon and the receiving beacon. And we also have to have in mind that a correct direction indication only is possible as soon as of the receiver, both antenna, X and Y antenna, receives a signal. It's like a vector, and the mathematics behind gives you the direction to the transmitting, to the transmitter to follow the flux line to the transmitter. So based on this, and I keep on going with the range topic, we are talking about these different coupling positions and what this means for the receiving range of a beacon. So the really best coupling position you have if you have the transmitter and in axial position the receiver. Here, this is really the maximum, the 100% receiving range. This becomes less if you have a perpendicular in 90-degree position between the main receiving antenna and also the transmitting antenna. And the worst coupling position you will have if you have a vertical transmitting antenna to your receiving antenna. This reduces about the half of the maximum possible range if you have the best coupling position. So useful is really the worst possible coupling position to know and to deal with, right, as a rescuer, because you have no idea, right, in which coupling position you are to the victim, because the one is in the snow, I'm outside, I'm moving around, yeah, but easily I have a worst coupling position, and from recommendations which search width you should use, in our knowledge and experience, the rescuer have to deal with the worst coupling position to cover all other possible coupling positions to find each victim fastest possible. But we do not have only this X antenna. Yeah? We also have a second one, the Y antenna. And how does this look like? It is more or less the same, right? It is the same, but here on this example, yeah, the best, the 100% receiving range you have always in this axial position. And the worst again is in this vertical position of the transmitter to the receiving antennas. And the really worst is if you have different sizes of antennas and different receiving ranges of X and Y, then the really worst is the shorter and to a vertical transmitter. So how does the shape look like, you know? And this yellow ball, you know, this is a circular receiving shape. If you have a vertical transmitter, it reduces about 50% of the performance. And what's really a useful range, this is the smallest axis. If you have a beacon with different antenna sizes inside or different strong antennas, then you have an elliptic shape. And also here, it reduces the receiving range 50%. This means what is the useful range now you really can work with? It is again the smallest axis. Well, based on this, the PIEPS recommendation is for the search strip width always to take the double of the useful range, because here you use really you use a range which covers all different coupling positions, because you do not know what the victim really has a position compared to you as a rescuer. And you do not have to think about if you have as a rescuer to support your search beacon to change coupling positions, to rotate or whatever. You only have to take this search strip width and run over the field until you have a first signal, and then to follow the signal as soon as you have it on your display. So useful range and how to evaluate and determine the useful range. This is what I want to show you, how we do that. And this is also, you can repeat that by your own. What we have here, this is a test field 50 to 50 meters. We have over here a receiving beacon, receiving with all included antennas. And we have a transmitter here in this edge in parallel coaxial position to the receiver. We change this during this test in perpendicular position and also in a vertical position. We start with the parallel coaxial and we run every 5 meters, and we are only doing what the receiver tells us to do until we overrun it and do not receive any signal during this run. And in this example, that would be at 20 meters, for instance. So how does it look like? We test this with a very accurate GPS, with a DGPS, differential GPS, and we measure the distance in meter, the velocity in meter per second, and in this way, you know, we started here going with this speed. Here at this point 1, we had the first signal on the display, and from here we did only what the receiving beacon told us to do. We did the same at 5, at 10, 15, 20, etc. And you see here the trajectories based on the flux lines the transmitter transmits. As I said before, you never go direct to the transmitter. Yeah, and we track also, and we measure here some different parameters like the direct distance, like the distance of the trajectories, etc. So if we do that now with all the different coupling positions, you see always starting on the parallel, on the perpendicular, the same. And here the flux line, it goes this direction, and here we meet it and we go exactly the flux line and not direct as it would be when you go in a parallel coaxial position. In vertical, it looks like this, because here we have this 3-dimensional shape. And when we want to analyze here out of that, the useful range, then in the parallel coaxial position, it is at the 35 meter, it is a useful range, 40 meter on the perpendicular, and on the vertical 30 meters. So the useful range here on this beacon and in this example, that would be 30 meter, means a search strip width, a recommended search strip width of 60 meter. And this covers really every possible coupling position between the transmitter and the receiver, because the vertical is really the worst one. And here on this 30 meter trajectory, you see we have also a reliable signal at 35. This one missed. So 30 meter is really the lowest result. And based on this, the recommendation comes up. So for the PIEPS beacons, you know, and here we do it with on the vertical, for instance, to give you an overview of the current beacons. We have on the micro fleet the 25 determined based on this chessboard test, as we call it, and on the 30 meter with the powder and with the Pro BT beacon, it is a 60 meter search strip width based on this useful range evaluation. Summarized, the useful range is really this range everybody can work with. The stressed guy in a rescue situation, a beginner, a trained guy, everybody. You have not to think about how to support your beacon to change coupling positions or to be faster, etc. The beacon helps you to be fast. So it gives also a reliable receiving signal and a correct direction indication on the beacon. And this without, as said before, without any support of the receiving beacon. And it covers all possible coupling positions. This is really the advantage of a recommendation of the search strip width based on a useful range evaluation. Well, so from this theoretical input, I hand over now to Laura, and she follows up now with the fastest rescue system.
Welcome also from my side. My name is Laura Marx and I'm the product manager at PIEPS. So like Markus already said, I will start off with the fastest rescue system. I guess like most of you know, time is a crucial factor in avalanche rescue. So we want to speed up the search as much as possible. One fast search strategy is called the fast rescue system, and it basically combines a beacon with an electronic probe. This is the iProbe. So there are basically two central questions. We ask ourselves at which point we can save time still during the search process, and the second central question is at which point can the user be supported by the most modern equipment. And the answer basically is that we can optimize during fine search and pinpointing. And how can we do that? This is by using the electronic probe. The iProbe, the electronic probe, gives 60% or results in 60% time saving during the search process. Fine search and pinpointing in general take 2/3 of time during the search phase. So 30% go off with the core search, and then you have fine search 45% and the pinpointing 25% if you're using a standard probe. Timings are about on average 52 seconds for the fine search with a standard probe and 29 seconds for pinpointing. With the PIEPS iProbe, this time is reduced to 21 seconds for the fine search and 12 seconds for pinpointing. So this results in the 60% time saving. But what is actually such an electronic probe? What is the iProbe? What are the functionalities? So in general, the iProbe is an electronic probe, which gives you acoustical as well as optical support during this fine search process and also during pinpointing. So to activate the iProbe, you simply tension the probe like you would do with any other standard probe. And to switch it off, you basically just release the tension and fold down the probe. If you use, if the iProbe is switched on and you move within a range of 2 meters of an active transmitter, the iProbe gives you a proximity indication. So this means the blue lights are flashing, and they do that in the interval like the beacon transmits. And also gives you an acoustic sound also in the interval the active transmitter transmits. This proximity indication is given between 0.5 meter and 2 meters away from the victim. Then if you move in closer and the active transmitter, the victim, is within 50 centimeters range, the iProbe shows a hit indication. So you have the blue light stays on, and you have a long beep sound that indicates a hit. So this is very helpful because actually with the iProbe, you don't have to hit the victim directly, but it's enough that you're close to the victim, and shuffling can already commence at this time. So this saves you time during the rescue. So what is the search strategy basically when using an iProbe? In case of a single rescuer, if you go through course search and find search, at course search it would work like this. The single rescuer commences the search like they would in a usual way, and if the distance is less than 10 meters, the speed is reduced. Then for the find search, like you would do normally, you go to the snow surface and find the smallest value. The usual crossing with the beacon you would do to define the point where you start probing, this is not necessary. You could do this using the iProbe. Ideally, you will already gain a hit while doing this, or otherwise you have to start probing in a certain method afterwards to find the victim. If you have multiple rescues, so this means 2 or more, there's also already a change in the course search phase. So if the distance is less than 10 meters, the searcher can tell the second rescuer to unpack the iProbe. And then during find search, beacon search, and probing goes along with each other. So the person having the iProbe will walk in front of the beacon searcher and start probing in an 80 centimeters corridor, middle, left, right, in front of the beacon searcher. So in this way, crucial time can be saved and the victim can be found faster. Next, I want just to briefly talk about external influences and interferences. So I guess like you all know, all beacons react to interferences. What are interferences affecting beacons? These are smartphones, metals, magnets, radios, video recorders like the GoPro, but also aluminum packaging, like for example, chocolate that's wrapped in aluminum. What happens if the beacon is subjected to such interferences? So during transmit mode, this means that the signal strength is reduced. Here you can see a beacon and also the electromagnetic flux lines around it. And if you put an interference, like a mobile phone, for example, on the beacon, these flux lines, the signal strength of these flux lines is greatly reduced. During receive mode, this also means a range reduction, but also that distances can be wrong, the distance indication can be wrong, direction indication can be wrong, and also maybe the number of victims is wrongly shown on the beacon. So this external influences and also interferences have a massive influence on how fast, how quick a victim gets rescued. So it's really, really important to do something against external influences and also interferences. So what are the things we can do? The approach from PIEPS is general that we have in transmit mode. We have the so-called auto antenna switch. This is a protection in send mode. So when an antenna is subjected to an interference, it can be a mobile phone, then the beacon automatically switches to the other antenna. So to always keep the strongest signal alive, basically. So the antenna with the strongest signal can be sending. Here I can show you a video of how this works, so maybe it's more clear. So here you can see that the beacon is sending with the strongest antenna, which is the X antenna. When you put the mobile phone close to it, it switches and it now sends with the Y antenna. If you hold the beacon next to the Y antenna, it switches again to the X antenna and so on. So this process is repeated here in this video. Further, PIEPS also has a protection during the receive mode, during the search mode. This is the so-called signal verification. This makes sure that only signals sending at 457 Hertz get registered by the beacon. And this means no ghost signals are notified by the beacon. The general recommendation is to cope with interferences, to keep the interferences more than 20 centimeters away from the beacon during send mode, and more than 50 centimeters away from the beacon while searching. This can be tested very easily. For example, if you want to see how the mobile phone influences the transmission power of your beacon, you can just perform a simple range test. So you have the transmitters in the best coupling position. You mark the first receiving signal. Then you interfere the transmitter with a mobile phone and then perform another range test and mark the first receiving signal again. And then you can observe that there is a big difference between the first range without an interference and the second range you obtained with the interference. So this is made quite clear with such a test. So again, just to mention, this is very important to keep interferences away from your beacon in order to, so it can function correctly. Well, that is it from our side. Thank you, Emma, for having us, and we are happy to receive your questions.
It's Hermannix.
Hm?
Oh, sorry, I've been muted this whole time.
Oh, okay.
Thank you both so much. That's a lot of information, really interesting, and excited to like watch this again later and absorb it a second time. I'm just like,
yeah, but it is recorded, right?
It is recorded. Yes. Yep. So
yeah.
Anyone can watch it again. Folks in the audience, do you all have questions for our panelists? Feel free to drop them in the chat, or you can raise your hand and I can give you speaking privileges if you have questions. Or if, like me, you're just like absorbing all of this information. I can also, if it's okay, Laura, with you, I'll put, oh, here we've got a question in the Q&A. Let's see. Okay, this person asks, I have a lot of challenges in getting across the point of interference to students. Any thoughts on how to impress to students how important this is?
I guess the range test I just showed, I think this is a really good test to show what happens with interferences. You don't have to perform a max range test, but maybe reduce it to 5 meters. I think that's the first thing, how you can really show how the range is reduced by interferences. Another test to show the auto antenna switch, for example, for PIEPS beacons is the video I showed. So this can be shown really easily also in the field. And another thing I think what is great is also to show the signal verification PIEPS has. For example, if you turn on a beacon and then put the mobile on search mode and then put the mobile phone close to it, you can see if it receives a signal, even so there is none. So this would mean that it's not resistant to ghost signals. And I think this can be really done with beacons, for example, in a group, and see which beacon, for example, is also resistant to interferences basically in search mode. This is a great test. So these three points, I think I would suggest. Do you have anything to add?
No, nothing to add. It's perfect.
Great, thank you. Okay, next question. Have temperature checks been performed on the iProbe? So does temperature impact it, especially cold temps down to like -20?
As far as I know, the functioning range of our iProbe is -15 to -15 degrees, goes down to -15 degrees, or -20. Do you know for sure, Marcus?
Up to -20.
-20.
Same as the beacons.
Yeah. So -20 degrees, it's still functioning. I think that's actually for all beacons, they have similar ranges. Yeah.
Great. Okay, thanks, Al, for that question. Devin asks, does the audible beep relate to signal strength, or is it only that you have a signal?
So the audible beep in a range of 0.5 to 2 meters, it basically follows the intervals where the beacon sends. So if the beacon sends, for example, every 500 milliseconds, you will hear a sound every 500 milliseconds. And then there is the sound stays long if you are closer or in a range of 0.5 meters within a range to the active transceiver, then it's just a sound that goes through.
Great. Thank you. And then
Yeah.
I know you've like got all the questions, Laura. Bruce asks, what is the optimum speed for the fine search?
Yeah, as said before in the presentation, each transmitter transmits about 1 time in 1 second. Yeah, so it is defined by the standard with 700 millisecond up to 1,300. So 1,000 is about 1 second. Yeah, so this is how you can measure it. You know, if you say 1 second and you move in 1 second over 1.5 meters, you know, you perhaps miss something inside. So go down to a much slower speed, but this second helps you, you know, to figure out your right speed.
Great, thank you. Folks, it looks like the speed of questions coming in has slowed down. So if it's okay, Laura, is it all right if I share your email address in case folks have questions later?
Yeah, sure, that's great. I'm
Great.
happy to answer questions.
And then a couple of folks in the Q&A have asked if it would be possible to share your slides and that video that you shared for them to peruse later as well.
Yep.
Yeah, sure.
Great. Okay, I'll have you, you and I can connect later and I'll get those. And then folks, when I always share the recordings with people who registered and attended the webinar. So I will, folks who are attending, I will share a recording of this webinar along with the slides and a link to that video. I'm going to just put this link in the chat for everyone. Obviously, if you've made it to this webinar, you know about this landing page where all of our webinars are, but we have a couple more coming up. Jonathan Schatz, who's on the call right now, it looks like we'll be doing a comparison of a bunch of different beacons and talking about actually a lot of the same themes that were touched on here, but Jonathan knows beacons really well. So I'm excited to have him talk a little bit about a lot of the beacons that are on the market. And then we'll have one other on February 2nd as well. So check those out. That link that I just dropped in the chat is also where you'll be able to find this recording and recordings of all the other webinars we've had so far. With that, I'm going to let you folks go, Marcus and Laura, because we really appreciate you staying at the end of your long day. And I think that is it for now. So folks will get in touch with you if they have questions. Thank you so much for joining us. This was great.
Thanks as well. Thanks, everybody. And please reach out if you have feedback or questions. We're always interested in getting that. Helps in our process of continuing improvement.
Awesome. Yeah, we have a feedback link that we'll share with folks. So I'll let you know what feedback we get from that.
Perfect.
Awesome. Okay, thank you both. Have a great evening.
Thank you. Bye-bye. Have a good day.
Bye.
Bye.